Hey everyone, and welcome. Got a big geography exam coming up? Well, you're in exactly the right place. Today, we're going to go on a complete journey through our planet, from its core to its highest peaks, to review everything you need to know.
All right, let's dive right in it. We're going to break down all the key ideas, all the important words, everything you need so you can walk into that exam feeling totally prepared. Sound good? Let's get started.
So, our journey begins deep inside the Earth. See, to really get what's happening on the surface, we first have to understand what our planet is actually made of on the inside.
I want you to think of the Earth kind of like an onion. Seriously, it's not just one solid thing, it's made up of different layers. On the very outside, you've got the super thin crust. Underneath that is the way bigger mantle, and right in the middle, that's the core.
The crust is the layer we all live on. It's where we are, right now. It might seem huge to us, but it's actually the thinnest of all the layers. You can think of it like the skin of an apple, really thin compared to the rest of it.
Now, the crust isn't all the same. There are actually two different types. You've got the continental crust, which is thicker and makes up the land we live on, and then you have the oceanic crust, at the bottom of the oceans, which is much, much thinner. Okay, let's go a layer deeper. Under the crust, we find the mantle. This is a huge, super hot layer of rock that's kinda gooey. It's not quite solid, not quite liquid. And this hot, moving rock, it's got a special name: magma. And when I say hot, I mean really hot. We're talking 3,000 degrees Celsius. This insane heat makes the magma move around in big circles. Kind of like water boiling in a pot on the stove. The hot stuff rises, then it cools down and sinks again. This movement is called a convection current. Now remember that name, because this is the engine that actually moves our continents. And finally, we've made it to the very center, the core. It's made of metal, and it has two parts. The outer core is so incredibly hot that all that metal is liquid. But the inner core, right at the very middle, is actually solid. Now why is that? It's because of pressure. All the other layers are pushing down on it so hard that it squeezes the metal into a solid ball.
So you might be wondering, what does all this heat and pressure deep inside the Earth have to do with us? Well, everything. It actually makes the ground we stand on move. Let's take a look at how. You see, the Earth's crust isn't one solid shell. Nope. It's actually broken up into these massive puzzle pieces. We call them tectonic plates. And remember those convection currents in the mantle we just talked about? Well, they act like a giant conveyor belt, slowly moving these plates around.
The places where these plates meet are called boundaries, and at these boundaries, they can do one of three things. They can move away from each other, that's divergent, they can crash right into each other, that's convergent, or they can just slide past each other, and that's a transform boundary. This movement is what creates almost all of the amazing landscapes we see on Earth.
So, when these giant plates start pushing and pulling and sliding around, they create some of the biggest, most incredible features on our planet. They build giant mountains and fiery volcanoes.
Now, mountains are basically built in two main ways. You have fold mountains, which happen when two plates collide, and the rock layers get squeezed and pushed upwards. It's like pushing the ends of a rug together. It wrinkles up in the middle. Then you have block fault mountains. This is when the crust actually cracks or fractures, and huge blocks of rock get pushed up or fall down.
Volcanoes are another awesome result of all this action. Deep underground, that hot magma collects in a big pool called a magma chamber. As pressure builds up, it forces the magma up through a kind of pipe called a chimney, until it erupts out of the crater at the top. And here's a key detail. When that rock is underground, we call it magma. The second it reaches the surface, we call it lava. As that lava cools and hardens, it builds up layer after layer, creating that classic volcano cone shape.
Okay, so we've talked about the forces inside the Earth that build things up, but that's only half the story. Once things like mountains are created, forces on the outside of the Earth start to shape them and change them. We call these external forces.
And one of the most powerful external forces is just water, in all its different forms. Just plain water can slowly dissolve certain types of rock over thousands of years, creating amazing caves. A fast-moving river can carve out deep, V-shaped valleys. And when water freezes into giant glaciers, they can scrape out huge, wide, U-shaped valleys as they slowly move. Of course, it's not just water. Wind is another huge player. It can wear away rock and build massive sand dunes. Just changes in temperature, from hot to cold, can cause rocks to expand and crack apart over time. And hey, Don't forget about us. Humans change the land all the time when we build cities or dig mines.
Okay, now that we know how land is built up and then worn down, let's do a quick tour of some important words you need to know, especially for the coast. That's where the land meets the sea.
Here are 4 key terms for your exam. A cape is a piece of land that sticks out into the sea. A bay is the opposite. It's where the sea cuts into the land. An island? Well, we all know that one. It's a piece of land with water all the way around it. And when you get a whole group of islands together, we call that an archipelago.
So our planet is powerful, and it's always changing, which is pretty amazing. But sometimes these big changes can be dangerous for us. We call these events geological hazards.
The first thing you need to know is that most earthquakes and volcanoes don't just happen randomly. They happen in very specific areas, usually right along the boundaries between those tectonic plates. The most famous zone is called the Ring of Fire, which is this super active belt that goes all the way around the Pacific Ocean.
So what exactly is an earthquake? Well, it's a violent shaking of the ground. It happens when all this pressure builds up along a plate boundary and is then suddenly released. The spot underground where it starts is called the hypocenter, and the point on the surface, right above it, is called the epicenter. That's usually where the shaking is the strongest.
Now, how do we measure earthquakes? This is super important. There are 2 main scales, and they measure different things. The Richter scale measures the magnitude. That's how much energy the earthquake releases. But the Mercalli scale measures the intensity. That's the damage it actually causes to people and buildings. So one measures energy, the other measures damage.
So there you have it. From the fiery core, to the moving plates, to the power of wind and water, we've seen that our planet is always in motion. It's constantly building new things and shaping what's already there. So, the final thing to think about is this. Now that we understand all these incredible forces, how can we use this knowledge to help us live more safely on this amazing, active planet of ours? All right, that's your review. Good luck on your exam. You're going to do great.